Hi, good morning, everyone. Can someone just confirm if I'm audible? So we'll wait for a minute before a couple of minutes before we get started for the day. Meanwhile, if any one of you can just post it in the chat whether my voice is audible or not. Perfect then. So let's just wait for one more minute and then we can get started. So today we are going to cover GCP Compute services. Okay, I think it's good to start now. Very good morning to all of you. Thank you very much for your time and thank you very much for joining in for the session. Today is the second day of Fundamentals of GCP Cloud, GCP Google Cloud Platform, and today we are going to cover GCP Compute services, right? So here's just an agenda of the entire workshop, and out of that, the first day we had an overview of what a Google Cloud platform is, what is the global construct, what are some of the logical boundaries that are part of the Google Cloud platform, how is it defined, what are the benefits of it. We also understood, at the very beginning, what are the benefits of the public cloud platform and why one should use it. And at the end of the session yesterday, we also went through some of the benefits of why one should develop the skill set or competency around public cloud platform, and so that was about it. As per the agenda, today we are going to cover about GCP Compute, which is nothing but your infrastructure as your service. Okay. Also yesterday, one of the topics that we did not discuss, and I had mentioned that intentionally we are not going to define or differentiate between infrastructure as a service, PaaS, and a SaaS, because that's something which I wanted to cover today. Because that's something which will also help us differentiate the reasons or use cases why an infra as a service or a PaaS or a SaaS is chosen whenever we go for a deployment. Let it be a greenfield deployment or be it a migration, right? So today we will be covering the differentiation between these three services, and then further we will go ahead to understand the compute services of Google Cloud Platform and very simple use cases. The use cases that I will be projecting will be a simple single tier, not a single tier, a two-tier application. But I will also be additionally sharing my experiences whenever we are designing a compute service for our clients. What is it that we need to understand before we spin up the first instance? How is it that the approach has to be developed both at the client end as well as the solutioning end? So I'll try to share my experiences with you as we cover the various services under the compute umbrella. Okay. So yes, the first section is infrastructure as a service, PaaS and SaaS. So we will try to differentiate this. The first and foremost thing, let's understand how are the infrastructure, the application, and the various other tiers are constructed or placed when you have the infra on premise. Now, what happens is in an on premise environment, you see the basic building blocks of networking, storage, and servers. And then on top of that, you may have your virtualization layer, you may have your hypervisors installed on it, so that you can run multiple machines on top of your same set of hardwares. So over the virtualization, you will have your operating systems installed, then you'll have the middleware, runtime, data, and application. Now, what is noteworthy over here is that all of these layers are managed by the on-premise owner, the customer. Basically, if I'm hosting my own data center, I will have to manage all of it, right? But when we start talking about providing these blocks, the blocks which are there on premise in form of a service, there are three ways by which I can do it. First one is infrastructure as a service, which is typically what happens when you go for a colo provider. Okay, and this is not just restricted to public cloud, but it is also something which is provided by a colo provider. What is a colo provider? Co-location provider. We have companies who develop the data center and then they lease data centers to users, to consumers. In that case also, it is counted as an infrastructure as a service. Now what happens there is the networking, storage, and the server, all the hardware part of it, and the virtualization layer, everything is managed by the provider. Okay, this provider, as I mentioned, can be a colo provider or a public cloud provider also. Once we request the infrastructure, what we get to manage, what we get to control is all the layers above this. So the operating system is in my complete control, the middleware of my application, the runtime environment, the data, the database that I will be installing and I will be storing on it, all of this, including the applications, writing the application, managing and maintaining the application, all of this will be something which I will be controlling. And same is applicable when it comes to security also, availability also. When it is about the security and availability of these components which is managed by the provider, they will take care of it. And say similarly, the availability, fault tolerance, security of anything that I'm running on top of these layers is my responsibility as a consumer, right? What is a use case wherein you would go for an infrastructure as a service? Think of a migration. Whenever we go for a migration, we have two options. First is, the most common one is rehosting. We call it an as is migration, or we also call it a lift and shift migration. When we don't have enough time, or let's say when the client or the customer who's moving on to the cloud is new to cloud, there is no sufficient adoption across all the layers, all the teams. It is very important that we do an as is migration, right? So that comfortably lands onto the cloud, starts understanding how the cloud infrastructure works, how the provisioning work, how the pricing and the security part of it, all of these components work, so that there is enough adoption. So when a client is new, so typically when I'm consulting with my client, if I understand that the adoption of the cloud platform is not much, I let them migrate as is on an infrastructure as a service, which means the VM that is running on premise, the same VM would be running on the cloud. The only difference is, instead of on premise, it will be running on public cloud. So there is no change in the way the developers, the infra owners were working. There is no change in the experience. The only change would be the elasticity, the on-demand nature, the pay-as-you-go payment model. All of these would change, but yes, the experience would be the same. The teams would continue to function the way they were doing, the way they were connecting and accessing the application. And then as the adoption happens, right, then we talk about optimization and modernization. When we talk about optimization, we talk about platform as service, then we talk about containerization, microservices, and further we talk about utilizing SaaS services also. But to remember, your as is, your lift and shift is something which happens on infrastructure as a service. One of the other reasons why we will migrate to infrastructure as a service is when, let's say, the time frame is very less. We have a stringent time frame to migrate onto the cloud. What could be the reason? The reason could be your data center contracts are expiring, your colo contracts are expiring, your hardware is due for an end of support, right? Or maybe it's in a critical stage, it's not in a healthy state, there are hardware failures, and the support is going to end very soon. You just have, let's say, 15 days or a month or 2 months max to max. So depending upon the complexity and the size of the infrastructure, it is best that you do an as is migration. There are tons of tools available, third party tools and native tools available, which can help you do an as is migration without making any change to your application. This is one noteworthy thing. You do not have to make any change to your application. It's just like the way it was running on premise. Yes, there would be some change if the infrastructure which is running on cloud is not compatible. For example, you are running a Windows 2003 or a 2008 which is no more supported. In that case, you'll have to go for an upgrade. Of course, the cloud platforms are still supporting 2008 with some deadline, but yes, these are not the latest supported platform, so you'll have to migrate. So in case if the operating system or any of the components are not compatible, that is the only change that you will have to do. But which is the case in whether you're moving on premise, or whether you are on premise, or whether you move on to the cloud, you will have to do that upgradation. So except for that, there is no change in your application code or anything of that sort. That's why as is migration is something which is we achieve within infrastructure as a service. Now comes the next stage. Now let's say when the client says that they want to run a very lean IT operations team, and at the same time they want to focus more on developing and managing the data rather than managing and maintaining the operating system, the availability of the infrastructure, the fault tolerance of the infrastructure. So in that case, they move to a platform as a service. A classic example of platform as service would be a database. So when you have think of a database support functions. What are the support functions? You will have a hardware engineer, then you will have an operating system engineer who will be taking care of your operating system patching and availability and everything of that sort. Then you will have a database engineer who will manage the clustering and everything, every other component of your database. Then the DBA, who writes your queries, who creates and manages your databases and optimizes your queries. Now all these functions are somewhere also a point of failure. If your operating system is not working fine, it will impact your database. If your hardware has an issue, it will impact your database and availability of that. uh, when we have moved on to the cloud, hardware is something which is now completely out of you don't have to worry about it, but the operating system is still your that we have to manage, right? So we want to do away with the runtime, the middleware, the operating system and everything, but we want to focus only on applications and data. So I will choose a platform as a service. The clustering, the backup of your database, the availability of your database, fault tolerance, all of these overheads are taken away when you move onto a platform as service. So you get more time to innovate, you get more time to work on your database, you get more time to work on your application. An example of platform as service, as I mentioned, is your relational database offerings from Google Cloud or any other public cloud platform. You also have app services or app engine, wherein you don't have to worry about the runtime environment. You just have to write your application, package it and push it, and the Windows patching, Windows availability, or Linux patching and availability, everything will be taken care by the public cloud provider. So this is the reason for moving on to the PaaS is when you want to do away with the overhead of all the other components, the ones which are highlighted in red. So this will now be managed by the provider, and you have to focus only on the application. Now there could be another scenario wherein your purpose of some business function or some application which you had developed is now available as a service completely. So why is it that why should we even invest our time and money and effort in creating that application, managing, maintaining it? So better go for a SaaS service. I'll give you an example of an email, although not the best example. But then, would you prefer writing your own application for email, or would you prefer using a Gmail service or an O365 service? It's always better to go for these SaaS solutions, because you require certain functionality which has already been built. All you have to do is subscribe to that service and start using it. Similarly, you have CRM, which is available as a SaaS. You have many such services which is available as SaaS. All you have to do is subscribe for the number of users for which you need that service and start supporting your business functions, which means you don't have to write anything. You see, every block becomes read over here. It is managed by the provider. All you're doing is subscribing to that particular service and using it as per your need and requirements, right? So I've just highlighted one of the advantage of infrastructure as service is reducing the capital expense. The fastest return on investment is infrastructure as a service. PaaS and SaaS, not SaaS, sorry, moving on to a PaaS platform, modernizing your application into microservices, and moving into a Dockerized kind of environment, containerization. All of these are good to have, but they also have a lot of overhead before that modernization happens. What is that overhead? You'll have to have your vendors or your application developers make a lot of changes to that, so it will take time before you start realizing the benefit. So the fastest return on investment is what you achieve in infrastructure as a service. You can very easily and very quickly free up the data center space, as I mentioned, rapid return on investment. And when you wish to have complete control of the application and the underlying operating system, it could be for compliance reasons. Probably you have your own hardening standards. So, and that is something which can be achieved only when you have control over the operating system. So if you want to achieve any of these points, go for infrastructure as a service. For a platform as service, what are the key points to remember? Faster and shorter updates. When you move on to a platform as a service, you get to focus on your applications, on your data, and hence you will be able to provide updates and changes to your application faster, because the overhead of operating system and all the other components below that is something which has been taken care by the public cloud provider. A greater cloud efficiency, which means the resource, the speed, the cost of it, the management of it, the backup, fault tolerance, high availability, all of this is being taken care by the public cloud provider. Of course, I mean, you'll have to configure, enable these features. But yes, all of these features are available as a managed service, which means your overheads have been taken away. And freeing up of data space and achieving rapid return on investment are still the same point. Why this is common between infra as a service and platform as services? Because we have seen during migration many a times client also agree to migrate to a PaaS database or a PaaS application platform, right? Because there are tools available which help you assess, which help you find what are the incompatibilities that needs to be taken care before you migrate to a PaaS platform. Once you fix that, there are tools available to do an automated migration. So even that can be a rapid migration, but as I said, it will still require some changes to be done. But yes, it again also helps you to achieve a rapid return on investment for your cloud migration. Then SaaS, yes, minimize the application cost. In fact, completely eliminate the application development and management cost. There is no need to develop, just subscribe and serve to your business context. Think of CRM services, think of your ERP services. All of this is available as a service now. App development and infra management overhead is completely eliminated. You don't need to look at it. Just subscribe the service, configure the business context that you wish to address, and start using it. So that is the advantage. Okay. So this is what I wanted to cover, which we discussed yesterday. That today, when we are discussing about compute, we will first try to differentiate between this. Before I start with the next section, which is typically approximately 20-25 minutes, let me know if you have any questions. Okay, so I don't see any questions as of now, so I'll move to the next section. Feel free to put it in the chat, and I will keep having a look at it in between, and then I'll also address it. So let's start with GCP Compute. What are the offerings of GCP Compute? So first offering, I mean, yesterday we discussed about, we just took an overview of what is a compute engine, what is an app engine, what is a GCP function. So today we are going to cover a little more detail about these services. So what's a compute engine? Pretty much your virtual machine, the virtual machine which you were running on premise, the same virtual machine can now be up and running on Google Cloud as well. What is the Okay. Yeah. So first and foremost thing, we need to understand the pricing model of this. The reason being, we are moving on to the cloud to achieve. We saw in our previous slide, the infrastructure as a service is something which helps you achieve a rapid return on investment. Now, the essence of public cloud is that you pay only for what you use. Now, when you say pay for what you use, what is that billing model? How is it that you will be charged? So we need to understand that the Google Compute Engine service that is available, they charge you on a per second billing. So if you have used something for some seconds, you pay only for that. The minimum unit, of course, will be 60 seconds. So if you have used something for let's say 30 seconds, you'll be charged for 1 minute, and so on and so forth. But imagine the amount of savings that you can do if you wish to run an infrastructure which need not be running 24/7, or probably you just need to spin it up for a few hours to do some test and small changes, and then shut it down. So you can save a considerable amount of money because of such kind of billing model. Now the other thing that the other benefit that GCP provides, and also which is a differentiating factor as compared to other public cloud platform, is a sustained use savings, which means let's say if you have not reserved your capacity. Typically when you reserve your capacity, you get a discount. Okay, but let's say if you have not reserved, you're just running an on demand infrastructure. In that case, if you're running your infrastructure, your compute engine, for a sustained period of time, typically let's say 25% to 30% of the total month, then in that case an automatic discount is applied to you. So Google Cloud tries to pass on the benefit of economy of scale to every customer, whether they have chosen a reservation model or an on-demand model. So if it is running for a sustained period, then a sustained usage saving is applied, and you get some discount. Of course, the discounting rules and models and various terms and conditions is something which we need to go through, because it varies from instance type to instance type. One of the condition that I have added over here, which is important to remember, is if you have created your compute engine as a compute engine service itself, or as a Kubernetes engine. Kubernetes is your orchestration for containers. If for these purposes, if you have spin up your compute engine, then sustained usage savings will be applied. However, I mean, in the coming slides, we will also discuss about the service called App Engine. If you have created your VMs, your compute engine, as a part of the App Engine, then you do not get any sustained usage saving benefits. So these are two things that you need to remember. But as I said, there are still a lot of conditions, the way sustained usage would be applied depending upon various VM types. For that, you'll have to refer to the documentation. What are the other pricing considerations? Whenever you create a compute engine, there are other services attached to it, like a disk will be attached to it, a persistent disk would be attached to it. Then there could be some other networking component like a load balancer or a DNS associated to that. You'll have your snapshot storage attached to that. So all of that will have its own pricing. Okay, so which means it doesn't mean that when you create a compute engine, for example, let's say a compute engine of 2 core and 4 GB has a pricing of $1, doesn't mean every other associate service will also be covered in that $1. It is something which will be having its own price basis the usage. One important thing that we need to know is in any public cloud platform, in fact, the data out, the data transfer out that is happening, you are charged for that. So through your compute service, whatever data is going out on the internet, we call it egress traffic, that will be chargeable as per the rates applicable. What are the windows, what are the environments supported? Your all your windows, all the latest versions and compatible versions of windows SQL and windows operating system, everything is supported. Your Linux flavors, the commonly used Linux flavors, are also supported. So as I said, it is pretty much the same VM which you are using on premise, you just get to migrate onto this. Some of the features, why is it that one should go for a compute engine? First and foremost, it provides you a live migration capability. You have tools that you can use for live migration, and hence, again, going back to the point of a quick return on investment, you will be able to automatically migrate your VMs in a very quick fashion to Google Cloud, and then you can automate your OS and patch management. Then at the same time, there are services like your sole tenant nodes. Now, let's say if you have a requirement to use your own licenses, right? There is on a public cloud platform, every public cloud platform, you have the option to get your own licenses, which is which is where we use the term bring your own license. If your license is covered under a software assurance, then you will be able to port this license onto the cloud. In that case, whenever you want to apply, you'll have to have a core, because most of the licenses are based or core or based on the number of hardware units. So in that case, you can go for a sole tenants. These are nothing but dedicated physical compute. So you will not get a virtual VM, you will actually get a dedicated physical compute. If you wish to use that in order to take advantage of your existing licenses, then you can go for a sole tenant node also. The configurations available are available in multiple sizes. There are standard sizes available, but one of the major benefit, or I would also say a differentiating factor of Google Cloud Platform, is that it allows you to customize your CPU and RAM, right? Which means in other public cloud platforms, the image sizes are fixed. So you may have a 2 core and 4 GB, and then a 4 core and an 8 GB. But let's say if you want 2 core and 6 GB RAM, that particular configuration will not be available. You will always have to satisfy your requirement by a configuration lower to that or a higher to that, but you will not get the same configuration that you want. But in GCP, you have the option to customize the CPU and the RAM, so that it suits your need, and which is where the concept of right sizing is very best achieved on Google Cloud Platform. And the other aspect to this is you also end up saving. Now, let's say for example, if you need a 2 core and 6 GB RAM, but it's not available. Let's say the nearest available size is 2 core 8 GB RAM. You will never have your application hosted on a configuration which is lesser than what is recommended. So you have no option, you'll have to automatically, and without any option, you'll have to choose the one which is having 8 GB RAM, correct? Which means you're also paying more than what you require. That is where the Google Cloud gives you an advantage. You can customize your VM configurations and achieve the right sizing. So this is one of the important features to remember. Now, here are different types. There are general purpose, and then there are again a general purpose category for higher performance and better performance, then memory optimize and compute optimize. You just need to remember this, because whenever you're doing some solutioning, you have to keep this in mind. Now, before we discuss this, let me share some examples of how is it that we do a sizing, how is it that we choose a VM type. Let me be very honest. Whenever we are talking to our clients, most of the times, okay, most of the times, we choose a VM which is having the lowest cost. That's the of course, that's not the best practice, but we always go by that. If the customer says that I need a 2 core 4 GB RAM, we typically see whether that 2 core 4 GB RAM is available in E series, N or M or C. Whichever is available at a lower cost, the client typically picks up that. as I will repeat, it's not the best practice. It is always recommended that we understand the actual utilization. Sometimes a 2 core 4 GB RAM VM, which is running on premise, is probably overutilized and requires an upgrade. Or it can also be possible, and very much possible, that the 2 core 4 GB RAM, which is running on premise, is highly under utilized. You probably need to downsize that VM. So it is always important whenever a client is sending a request for some kind of migration from on-premise to cloud, try to understand what is the utilization of that. And when I say utilization, you're talking about your min, max, and average, so that you can take extrapolate that information and understand which is the best possible size available to save the cost. Apart from this, parallel to this, you also have to understand the application, okay, which is where these definitions and these differentiations come into picture. So if you understand, if the application is a day-to-day computing, and it is serving some a nominal traffic for web and app, and for some small and medium databases, then in that case you have to go ahead and choose this E2 instance. So a combination of the utilization data and a combination of the nature of the application, you have to combine this and then take the best decision. Typically, in a larger in a case with larger number of VMs, it is best recommended and highly recommended that you go for an automated assessment. Automated assessment tools ensure that they read the utilization data and give you a recommendation basis the hardware sizing and also basis the workload utilization. So that is very important and very critical when you are taking a decision to migrate your infrastructure. So just quickly go through this. Let's say your E2 and N series are both general purpose instances, but here you see, these are day-to-day computing requirements at a lower cost. But this is the one wherein the price and performance both are kind of balanced, but it is typically recommended for large size databases, your large size web and app, the ones which are performance intensive, your caching requirement and media and streaming requirement. And then you have memory optimized all your in-memory database like SAP HANA, your analytics workloads, all of this for that M2 M series, a memory optimized series of compute engine is recommended. Then you have other compute optimized. Even your databases fall in this category because DBs are typically compute intensive, so your DBs typically should go in this type of VM. Okay, so very quickly I'll repeat that your choice of instance depends has to be balanced between price and also the performance requirement. Any questions so far? So there's one question. According to the service, we have to pay or not? Okay, so I let me paraphrase this. Probably you're trying to understand. According to the usage, do we have to pay or not? Yes, every thing that you pay is based on usage. The only thing that we need to understand is that every services on public cloud platform, not just GCP, has a different pricing model. A storage will have a pricing model basis the utilization of the storage in GBs, and then a different slab for TBs. Similarly, your compute instance has a payment model which is applied per second. Then we will go ahead and understand the compute function. You will see that over there the pricing is applicable only when you execute your functions. Okay, so it will count the number of transactions you have executed and the amount of memory that has been utilized while executing that transaction. So the what you pay, you basically pay for what you use. That is true, but yes, the pricing model will vary from one service to other, right? What are the services account for GCP? How do we create one? Okay, so maybe probably you're trying to ask that how do we create an account on GCP? It's pretty much the same way that you create an account for your Gmail and YouTube. It's just that there you'll have to provide your credit card information, so that you start paying for what you use. But yes, that is something which requires a little more coverage. As I mentioned yesterday, that unfortunately in these sessions I'll not be able to cover any of the labs. But yes, it's an important thing to understand that how is it that you create an account and get started. Probably you can just search some videos. GCP has a lot of tutorials on account creation, and before things you need to take care before you spin up your first service. Okay. So, what could be a typical example? Just a two-tier application wherein you have your users, you have your compute engine, wherein you have your application hosted, and then you have the database over here, and then the storage for your unstructured data. So this is where a compute would be used. No need to differentiate from the use case perspective, because it is, as I said at the beginning, it is the same VM as you are running on premise. So whatever you can run on a VM can run on a compute engine. So all use cases are applicable over here. Yes, there are cases when we are talking about modernization, then we try to consult our clients that compute engine may not be the best way to serve your application requirement. It's better to move on to a PaaS platform. It's better to move onto a containerization platform in order to have a controlled or a better managed auto scaling and availability and things of that sort. But the compute engine can serve pretty much everything that you can think of which runs on top of an operating system. You can have that thing running over here as well. So app engine, what is your application engine? This is a PaaS platform, platform as a service. So when you go back to the before, okay, I have a question. Is it generic for compute storage and other services? Krunal, and you'll have to be a little more specific. I think both these questions are related. Your previous question, your question earlier was, what are the services account for GCP? Is it generic for compute storage and other services? Okay, so maybe now I've understood more about your question. So once you have created your account, yesterday we discussed about the structure. You have your org node, then you have your folders, your project, and under that you have your resources. All your resources, be it your compute, storage, networking, security, DNS, edge services, whatever services are available, all of that will be part of the same account, right? It's just that the organization of those services will be under a project. Is that does that address your question? Just let me know in the chat if that addresses your question. Okay, we'll go ahead. So App Engine, as I was saying, if you go back to the definition of platform as service that we discussed in the beginning. When you want to do away with the overhead of managing the operating system, availability and scalability of it, fault tolerance of it, we go for a platform as a service. So App Engine is a platform as a service. Now, instead of having a Windows machine and then installing your application package on top of it, how about there is no Windows machine to manage at all? All you have to do is upload your package and get started, right? That's what App Engine provides. It is available for runtimes like a Java, PHP, Node.js, Python, and Go, and with an exception that .NET is available for a flexible App Engine environment. In the next slide, we will understand what is a flexible App Engine environment or what is a standard App Engine environment. But yes, if you have your application written with any of these runtime environments, a Java, PHP, Node.js, or Python, all you have to do is package your application and upload it to an App Engine, and it will start running. It takes care of your scalability, it takes care of your availability, patching of your operating system. Everything is taken care by the public cloud provider. So you see, the only thing that we need to remember is, for a standard App Engine, we'll see the differentiation. The billing is hourly, and for a flexible App Engine, the billing is similar to the compute engine billing that we did. So now I'll just quickly take you back over here. You see, I've mentioned one thing over here. Sustained usage is available for compute engine and Kubernetes, and sustained saving is not available for VM created under App Engine. So this is what defines when do we use VM for an App Engine. So whenever you are spinning up an App Engine under the flexible environment type, in that case you will be doing nothing but spinning up your compute engines. And in that case, the sustained savings would not be applicable. I'm just trying to relate what we discussed earlier. Okay, sorry if I've switched between too many slides. sorry if that confused you, but yes, I would just wanted to relate that the sustained saving in this case, because we are going to use a VM, the sustained usage saving will not be applicable, and the pricing will be again similar to the compute engine. You will be paying for every second with a minimum usage cost for 1 minute. Okay, again, cost for other associated services like associated databases, storage, and other things would be applicable. If your app engine is making an outbound traffic, which is an egress traffic, then the data transfer charges will be applicable. What are the runtime supported? Java, PHP, Node.js, Python, Go, and .NET. .NET is available only for a flexible app engine environment. Now let's see what is the mystery of this standard app engine and flexible app engine. In a standard app engine, in your application actually utilizes a Docker, or call it instead of saying Docker, I would say a containerized environment. You just have to upload your package, and it uses the standard available runtime environments, and then it starts executing for you. But over here in a flexible app engine, you actually get a VM. Okay, when you start this app engine under flexible app engine environment, you actually get a VM on which you upload the packages and have it running. It is more suited for application. The standard application engine environment is more suitable for apps which require rapid scaling, because over here you don't have to do any manual scaling. This is something which is, the auto scaling can be very easily managed by the public cloud platform itself. So whenever you know that the nature of your application traffic is something which you cannot predict, there can be a spike anytime, when there could be a need for a rapid auto scaling or scale up and scale down. In that case, it's better suited that you go for a standard app engine. But if you think that your application can scale up and scale down gradually, in that case you will use a flexible app engine. And in that case, autoscaler is a service of it's a feature of compute engine. You will have to configure that, so it's a manual configuration that you'll be controlling here. Basically, in a flexible app engine, you get a little more control of your applications, and you get to run this .NET as well. Over here you do not get to run .NET. Okay, so that's typically the difference. Let me first see if there is any. Okay, I'll just cover this use case, small use case, and then I'll see if there are any questions. Again, a two-tier application, the same application that we saw in the previous example, the same application, but instead of running a VM, I'm using an app engine, a PaaS platform. Okay, let me see if there are any questions. Okay, so no questions so far. Now this is the last topic. So we are now at function as service. This might sometimes creates a confusion that we discussed about infrastructure as a service, we discussed about platform as a service, and then we discussed about software as a service. Now what is this new thing called function as a service? In this cloud native world, everything is available as a service. That's why there's a generic term called XaaS, which means anything as a service or everything as a service, right? If you have, let's say, developed a security solution which you want to provide it to your consumers, your potential clients, you can call it as a security as a service. You can call it anything. That X can be anything. If you have an application which helps you better manage the containerized environments, you can develop that application and sell it as a container as a service. So the X can be replaced with anything that you want, depending upon what you have developed, what functionality you're trying to address. That's why the XaaS is a generic term. And similarly, function is something which is available as a service on Google Cloud Platform. Now, what is functions? We are actually talking about a serverless environment now. We don't get to see what is the backend service. The environment. You don't have to worry about the environment. You don't have to worry about the operating system. You just have to worry about the code that you wish to execute. Now, typically, what is a use case wherein you will be using these cloud functions? Let's say in between two services, a compute and a storage, or a database and a storage. Any of these services, they are talking to each other. Now you have certain event that should trigger an action, right? Which you want to automate. Then you will use as a function. So think of all the automation scenarios that can be implemented using a function. So I can give you an example wherein in our environment, what we have done is all the snapshots that we take for a particular machine, when we want to move it to a new region, what we have done is we have written a script which is executed as a function as a service. That what does that script do? It scans all the images. It will look at the naming, the labeling, we call it tagging. It will look at the tag of all the snapshots and see that which are the snapshots that are older than, let's say for example, 3 days. The moment they find snapshots older than 3 days, the function will delete those snapshots, and whatever is the latest 3 days snapshot, it will also make a copy of it in a different region as a dr copy. So these kind of automations, whatever automation scenarios you can think of, you can execute it with the help of a function as a service. So earlier what we were talking about, we were talking about the complete application package. My complete application may have different functions into it, but now we are just talking about one function at a time. This is something which we can achieve through a cloud function. Now the advantage of this is you pay only for the amount of time for which your function is executing. So let's say if you run a particular command through this function service, and if it is running for 1 minute, you pay only for that. In fact, the billing, when you go to see the documentation page, you have there'll be a count of functions that you have executed, and for how long it will be running, for how much memory it utilized while it was running. So there are various parameters, but typically using function as a service, you can save approximately 70 to 80% of your cost that you would have paid when you were using, if you had used a compute engine, right? So as compared to a compute engine, you can have a significant saving. You all must have heard of this platform, a very good, a very popular public cloud training platform, a cloud guru. You see that website, that entire website has been built up in a serverless fashion. Every time you open a page, it's actually a function which runs in the background. It pops up that page. When you click a video, the function calls that video from the, fetches the video from the bucket, and then starts streaming to you. So with functions, you can have a significant amount of savings, and you can achieve a higher degree of automation. Then the same points for other pricing considerations, the associated services will be charged, and the all the outbound network requests will also be charged. So these are the environments. You can write your function in these environments: Node.js, Python, and Go, which means you can write a lot of your Python automation and get it executed as a function of service. Now let's take an example. Let's say for example, you have a website wherein your users, your subscribers can upload their photographs. All the photographers, the enthusiasts in that field, you have created a platform for them, but you want to ensure that there are no images which are offensive. Probably you want to ensure that nudity is not allowed on your platform, and then some other offensive images, violent images, all of these images are not allowed on your platform. So you cannot literally scan all of the images and take a decision. It's better to automate that. Now what this flow shows is, the moment a user is uploading an image on the storage, right, a function gets triggered. The event, a function, a cloud function will always get triggered on an event. So what is that event? Event is uploading of image to the storage. A function will get triggered. It will call your automation script, which is of course running and written and running through this cloud function. It will start processing the image. It will start processing the image, and it will call the Google Cloud's Vision API. Vision API is the one which can scan the image and do a lot of comparative stuffs. It will call the Vision API, and then basis the logic that has been fed in that, it will take a decision whether that image is an offensive image as per your categorization or not. If it is an offensive image, the again another function will be called. That function will run through that image and render it into a blur image using let's say an image magic functionality, and then it will store it. So now automatically every time an image is uploaded, it scans it, understands, runs it through the criteria that you have defined, and if it is found to be violating the criteria, it will blur that image and then re-upload that image in the bucket. That way you will be able to control lakhs and lakhs of images that are being probably uploaded to your platform. So here you see function is being used to for using for having a collaboration between different cloud services. So that's where it is an advantage. You can build a lot of automation around the Google Cloud services. So as I said, this is the last section. We had planned. We had covered only these three services yesterday in the overview section, and this is what we wanted to cover today as well. So your compute can be is simply an infrastructure as a service. We can use it for anything, pretty much anything and everything that runs on your on-premise VM. You can migrate onto a compute engine. Then we had an option to use the platform as a service, wherein we can use an app engine for a more controlled environment, highly scalable environment. And finally, we discussed about function as a service, wherein we just have to focus on the automation that we need to build around the Google Cloud services that we are using. Any questions so far? So far so good. I don't see any questions as of now. We have finished today's session because there were just three services that we had discussed yesterday in the overview, and we wanted to cover that. I'll just quickly take you to what is going to be the agenda for tomorrow before we wrap up for the day. So tomorrow we are going to discuss about networking. In the networking section, we are going to talk about what are the various ways from which you can through which you can connect from your on-premise. What are the consideration for connecting from over the internet? Some of the security considerations. All of this is something which we'll be covering in the networking section, right? So that's it from my end for today's session. I'll just look at it for the last time if there's any questions. So I don't see any questions, so we can wrap it up for the day. I thank you all for your time and patience. Please feel free to write to me with your recommendations, with your feedbacks in terms of how this can be improved further. Yesterday, I got a recommendation that I should include some demo labs because that will make the session more interesting. But since this is just a fundamental session, the intention of this is to bring up the terms and terminologies, some of the common services, so that you are aware of it. Maybe in upcoming sessions we can focus on each of these services and do some lab as well. But as of now, as I said, I'll not be able to cover labs. Anything else in terms of how to improve this further, how to make these kind of sessions a little more interactive or interesting? If you feel there are some things that I can add, please write to me. It will help me improve. Thank you very much, and have a great rest of the day, all of you.